I want to look at one more type of problem, and I've selected an even number from our textbook. This is number 106. We're given this function g of x equals 6 cosine x minus 4, so that would correspond to a transformation of the cosine function. But we're also given a restricted domain. And you'll notice this is the same restricted domain we had when we were just working with cosine and restricting the domain to get a one-to-one function so that we could take the inverse. Okay. So by restricting the domain here, we're turning this transformation of cosine into a one-to-one function. And we're asked to find a formula for the inverse function and then state the domain and the range. Being very careful, we're asked for the domain and the range of the inverse function. Okay, so let's remember how that works. I'm going to write out the original function, but instead of using function notation, I'm going to write it in terms of x's and y's. So instead of writing g of x, I'm calling that y equals 6 cosine x minus 4, with this restriction that 0 is less than or equal to x is less than or equal to pi. That is part of the definition of g. So then I can write the inverse function by simply switching the roles of x and y. So x would equal 6 cosine y minus 4, and 0 is less than or equal to y is less than or equal to pi. So when I switch the roles of x and y, I do that not only in the formula, but also in the inequality that puts restrictions on one of my variables. These now become restrictions on y. Okay, and then I want to solve for the new y value. So I'm going to add 4 to both sides. So x plus 4 is equal to 6 cosine of y. Let's divide through by 6. So we've got 6 cosine y is equal to x plus 4 over 6. I'm not bothering to write this restriction every single time, but that is always understood to be part of this formula, and I'm going to want to make sure that I include it in my final answer if necessary. Okay. Whoops, I'm sorry. I divided by 6, so that 6 isn't there anymore. So now I still want to solve for y. I know cosine of y is this thing. I want to undo cosine. Well, as a general rule, I can't undo cosine. But if we've restricted things so that I know y, which is the angle here, is in this interval, so that it's between 0 and pi, then this cosine is cosine with that restricted domain. That's the function whose inverse is arc cosine. So I can apply arc cosine to both sides of this equation. I'm going to get arc cosine of cosine of y is equal to arc cosine of x plus 4 over 6. And because y is in this interval between 0 and pi, this is one of those times when this function undoes this. If I didn't have these restrictions on y, remember I need to be very careful with this function composition. If the angle I'm plugging in isn't in the appropriate interval, this isn't the inverse of this, and I can't just have them undo each other. But because y is in this interval, this just gives me y. Okay. So I have y equals arc cosine of x plus 4 over 6. Now, I still have this restriction that y is between 0 and pi. It actually becomes unnecessary for me to write that because I know arc cosine can only spit out those values. So I needed to know this in order to know that that was what I was plugging into cosine, but I sort of get for free. Those are the only values that I can get out of arc cosine. So my formula for g inverse of x, I'm going to write it using the inverse function notation. That wasn't explicitly stated in the directions, but often it will be. So as always, read directions carefully. G inverse of x would be arc cosine of x plus 4 over 6. Okay, now we were asked to state also the domain and the range of this thing. Okay. Now the range I pretty much have right here. Y is in the interval from 0 to pi. Okay. And of course, the domain of the original function, which was the interval from 0 to pi, becomes the range of the inverse function. Okay. But now I need to get the domain. Okay. Now I could get that by working with arc cosine. I could say the domain for arc cosine is the trig ratios that I could get from cosine. So that's the interval from -1 to 1. I'm looking for when this takes on values between -1 and 1. But I think it's a whole lot easier to say the range of G is going to be a certain interval. Now for G, that's an interval that corresponds to the Y values, but that's going to become the domain for G inverse. It just becomes a horizontal interval corresponding to the X values. And so if I take a look at the original function G, I can see I was just doing a vertical transformation of things. So with cosine, we would start with high, middle, and low values of 1, 0, and -1. Looks like we're multiplying by 6. So that would take me to high, middle, and low of 6, 0, and -6. And then we're subtracting 4. That's going to just move things down 4. So my high value is 2, my middle is -4, my low is -10. So I can see that the range of G would be the interval from -10 to 2. Those are the Y values I can get out of G, but that means those are the X values that I can plug into G inverse. So that fact that the range of G is the domain of G inverse is really powerful because we're familiar with how this affects the graph of G much more than we're familiar with how this affects the graph of G inverse. So I think that's the simplest way to find the domain of this particular function.